So now, let me talk about sound waves. And here is where the source of all confusion comes in. The scale that we use to measure sound wave intensity is called a decibel scale. You have seen this before. What is a decibel scale? So when we talk about sound intensity level, we call it SIL dB. There is also another unit that we know, which is called sound pressure level. It is called LPL. It is also measured in dB. There is another one that we call sound power level. And that is called SWL dP. And I have seen so many people so confused about all of these terms. And part of the problem is that we don't fundamentally understand what these terms mean. So sound intensity level is given by the formula 10 log of I over I naught. Intensity at the point. So I will be intensity at point I want. And I0 is reference. The lowest intensity anything could have. And that is defined as 10 to the minus 12 watts per meter squared. Sound pressure is the energy that's being radiated by the noisemaker. So it is the energy radiated by noise maker. It does not depend on positioning of the person, does not depend on the receiver. It only depends on what is making the noise. In this case, so energy per time is called power, right? So power was energy per time. And the units were watts. So the definition for this is 20 log of P over P naught for power, where P is the power we want and P naught is the reference. And P naught is defined as 2 times 10 to the minus 5 PA. Does everybody understand the unit Pascal? Everybody recognize that? It's a unit for pressure. Force per unit area, which is newtons per meter squared, which are called pascals. Another important thing you should know is atmospheric pressure. It's 1.01 times 10 to the 5 Pascal. Notice the difference between units. So remember, sound intensity level is what a person will hear. Sound pressure level is what the noisemaker will make.
Are they all decibels?
They're all in decibel. And that is the major source of confusion. But they're all measured in decibel. The reason why they're all measured in decibel is because of number 3. When we talk about the sound power level, SWL in decibels is defined as SPL, also in decibel, plus log of QD divided by 4 pi r squared. Again, every single thing is measured in decibels. So this is measured in decibels. That is measured in decibels. And that also is measured in decibels. Now, what's the difference between power and pressure? Here's a good way to think about it. What is sound power? Versus what is sound pressure? Well, they are related to each other. However, the people who are interested in studying them are different. Why do I say that? So who studies the power? Power is what the source produces. And sound pressure is what is heard at point P. So who is interested in this? So think about it this way. There is a light bulb there. It's producing light. How much of that light is reaching you? Depends on your location. So the light bulb is producing, say, 100 watts. But are you in this room receiving 100 watts? How much are you receiving? However much, wherever you are.
Depends on where. If I'm like on top of the light bulb, then I'm receiving
100 watts. So this sound pressure depends on your location. Another example I can give you is air conditioning in a room. Is the air conditioning producing the same amount of coldness? How cold are you? Depends on your location, right? Depends on your location. So that's the difference. Now, another major difference that you can think about is people who are interested in studying sound power. Who do you think wants to study sound power? It's their problem. Whereas who studies sound pressure? Sound engineers. Two very different fields. Both of them want to reduce the effect, right? But each of them will reduce it differently. Mechanical engineers will work directly with the machine, whereas sound engineers will work with the acoustics of the room, right? How do I lessen this problem that the mechanical engineers have created for me? Does that make sense? So sound engineers are the acoustical engineers who worry about, okay, if I need to make this theater, how do I get the most sound to the most positions in this room, right? How do I put the sound barriers and the reflectors and where do I put everything? Mechanical engineers don't care. They just need to make the noisemaker. Make sense?
Yeah.
Okay, so that's the way to remember the difference between power and pressure. They are two different things.